I work for DLR, and my first question is, who of you know DLR? That's great. And so you know what we do. That's perfect. Is it working? Still, if I look at the time, it's 4 p.m. at the second day, so I would like to start with a video to show you the activities that we perform at DLR and the variety of the research. I hope this works. Yeah.
Our destiny is always to go and see what's further and what's next.
Let's go.
Right, so as you can see, we have lots of different projects, lots of different topics that we are covering, but not all of us are doing research. So we have the research institution, but we also have the space agency, which represents the interests of the German government in Europe and worldwide. And we also have the project management agency. That's why you might know DLR as well, because they distribute funding from the ministries. Yeah, we cover aviation, space, energy, transport. So there are a lot of different topics and collaboration opportunities, of course. Some key facts, so we have 55 institutes all over Germany, also some sites abroad, and roughly 10,000 employees in all these locations. And our institute, or my institute, is the Institute of Maintenance, Repair and Overhaul. And we're located up in the north in Hamburg. And we were founded in June 2017, so we're relatively young and relatively small with 60 employees. But still we try to really position the research into this maintenance perspective, really covering those questions. We've heard some keywords today, Marvin. You mentioned predictive maintenance, and so these are like the really relevant challenges also in the industry that we are contributing to. And we also have labs. So we have a big MRO lab in this building in Finkenwerder. So who knows in Hamburg, they know it's the place where also Airbus is, south of the river. And we collaborate with Airbus, of course, and also other companies in this sector. Looking at our institute in terms of our strategic research, our vision is we maintain mobility for a sustainable future. And well, we do this with 3 dimensions. And these dimensions consist of, firstly, the product life cycle perspective. So really look at, okay, what are MRO concepts and strategies? How can we develop those along with the product life cycle? We look from the design phase until the end of life of an asset, of a technical asset, primarily as an aircraft, and look at the topics of environmental analysis and security. but also the cost-benefit perspective. This is the life cycle modeling. The second dimension, the second department is really looking hands-on on the maintenance technologies. These are the people working also in the lab and really focusing on, okay, what are technologies for assisting the human, human in the loop, for example, AR, VR assistance systems. Then we have the robot assisted inspection and repair, which is focusing on robot inspection, robot activities in, for example, engine maintenance. And we have the technologies for more data-centric MRO because, a lot of data is already in the aircraft by all the sensors, and the MRO equipment is also generating lots of data. So data is a good keyword for the last dimension, process optimization and digitization. This is where all the data comes together. Oops. This is where all the data comes together, and we try to work towards digital twins where we can analyze and perform those kind of future predictive analytics, AI-based models. So this is what we cover at a first glance, and I want to talk firstly about maintenance in general. So what is maintenance? If you look at the sky, we see the aircraft, and we don't think about maintenance, which is a good thing, because if you think about maintenance, it's a bad sign. So we hear about maintenance when we have delays in our aircraft, when we are hopefully not already sitting in the plane. But there are, of course, lots of different activities in maintenance. According to standard from DIN 13306, the main task is to maintain the target condition of the technical system, and it encompasses activities to aim to prevent failures, of course, restore functionality, and continuously improve the system's performance. So if we look at the right-hand side, this is the corrective activity. This is after detection of a failure. That's what you don't want to have, because then it's already too late. So then it's about, okay, where do we have, for example, a crack on the fuselage, on the wing? Where do we have it? How deep is it? What is the diagnosis? And then we try to, of course, repair it, maybe temporary, and to check if the function is still working. The better side is the left-hand side, because then you can get before the failure. So you try to be preventive. So first you can, of course, detect the fault by the function. So you do tests, you do function tests. Then you have the diagnosis of the degradation. So you detect, for example, by condition monitoring. So you have lots of data, lots of sensors, and you try to really monitor the health status of the component by, for example, inspection, regular inspections, non-invasive inspections, internal inspections. A lot of them are GVU, which is like a general visual inspection. For example, the simple one, which you all know, is like the pilot doing the ground check, going around the aircraft. And the last pillar is the preventive refurbishment, which is this active condition-based action. And this is also towards the perspective of prescriptive maintenance, where we really plan the schedule and plan the action before the actual maintenance failure. Okay, so far so good, but why do we exactly need maintenance? The answer is simple. Maybe going back here, this is the end of life here, and we want to really extend the life of the aircraft, and we don't want to see this we want to see it maybe after 30 years, which is the average lifetime. Well, it's simple. It's profitable. It's required to ensure safety. Sometimes we have to do it because of regulations, and sometimes we want to do it to save resources. So there are different motivations for companies, researchers, people, and you can only choose one of them, and it's still really relevant and critical. This is the picture that I told you don't want to see. So to sum it up, maybe maintenance is sustainability economically and ecologically by means of most efficient technical usage of resources. So we want to really have a sustainable operation of technical assets in the most efficient way. Okay, so what is the impact of maintenance for sustainability? What we can see here is the life cycle of a technical asset. Here is an aircraft. So we have the design phase, we have the production, we have the operation, which is the longest interval, of course. Then we have maintenance and end of life in the end. So what role does maintenance play in this life cycle? The answer is maintenance is underestimated. That's no surprise. If you look at it, we have, of course, lots of technologies, lots of activities going on around operations and production, but not so much about maintenance. And the impact could be, of course, longer asset life cycles, as I said, more efficient operations, because the engine, for example, if you regularly inspect your engine and repair your engine and keep it like maintained very well. It's the same with your car. You have also a more efficient operation, which is at least better for your budget and better for the environment. Then we have the third impact category, maybe, which is more sustainable MRO processes. So MRO, which is maintenance, repair, and overhaul, can enable longer life cycles, which is sustainable and efficient operations, but the MO process itself can also be greener. For example, reducing the waste, reducing the water usage, reducing the resources, minimizing and using the resources efficiently. So the MO process itself is also one potential. And in the end, also maintenance could be an enabler for new sustainable concepts. An example for that could be, we're talking about drones. And if I talk to the drone manufacturers, producers, they don't address maintenance, at least not publicly. And maintenance could be a really big challenge and could be an enabler for this technology, among others, of course. Or, for example, fuel cells. So if you want to use hydrogen or fuel cells in future aircraft, I'm sure you've read about it. There are nice, fancy concepts out there for the future of aircraft. Well, someone needs to think about maintenance, because without the maintenance technologies and concepts and processes, we cannot have these kind of sustainable propulsion technologies like hydrogen, battery, full electric, and hybrid electric. So these are the categories, and as I said, maintenance is underestimated for now, so it's starting to shift. So there's a new regulation, and you know it, it's the right to repair, which has a huge impact in the consumer industry. But yeah, we are closely observing this, because right to repair can really turn the mindset and the culture, not only consumer, but also in other industries, especially in the electronic sector, with this fundamental shift. And environmental regulations tightened, and consumer preferences change as well. So your brand can't really afford to view sustainability only as an afterthought. That's also the case for aviation. And some see maintaining or repairing things as important as innovating things, as we can see, especially during time of inflation, high prices, maybe during COVID as well, and also with higher interest rates and lower investments, maintenance plays a really more important role. And lacks the glamour of innovation. Let's phrase it this way. It's mostly, as I said, noticed in the absence. Maybe another perspective, what I caught in the news, repair is as important as innovation. So we have also this kind of direction, and yeah, some really criticize why it's like that. So we can see some positive perspectives now. Hey, the maintainers, we talk about innovation, but we are failing in maintenance. And some I say this matters even more than innovation itself. And in the end, we have the European Green Deal as well. And I was going through the law document and also through the proposal of this Green Deal. And maintenance was not mentioned at all. I don't want to say it's not, they didn't think about it. So there is, for sure, there is inspection and repair and everything. But, well, it could be more relevant in this kind of thoughts and concepts. So what do we do? Green maintenance. So Green Deal. So green maintenance would be the answer. What would be green maintenance? That's one question. And there are some studies out there. I brought you this figure which distributes or categorizes green maintenance into 3 pillars, which is the environmental compatibility, for example, leakage prevention, landfill problems, waste treatment policy. Then we have the energy efficiency, which is the ease of maintenance, for example, tribal materials, reduce friction, and paperless maintenance, of course. And also, if you think about remote MRO, minimizing unnecessary travel. So basically, you think about maintenance as a box, and the input for maintenance is the product to be serviced, and the output of maintenance is the service product. It's the maintenance waste and it's the energy wastage. So there are different potentials, and we have also constraints, which is the material, energy, labor. We have regulations and standards. We have the capability of the technicians. They also have to be trained, of course, because we have new technologies in the aircraft. The maintenance has to catch up. And you have also maintenance strategies evolving also with new technologies like AI and digitization. So these constraints pose requirements for good maintenance, which we can see here. Maybe it's similar also to ESG with the environmental and the social aspect. So this is the third one would be the social perspective, human health and safety risks, which is extremely important in maintenance sector for the mechanics to have like proper lighting, ventilation, safe maintenance steps, using of non-toxic lubricants, non-toxic materials. So what we did is I brought you some examples for each of these pillars to give you maybe a more concrete perspective on what kind of projects we work on. Before I do that, I want to show you one method that what we implemented, which is how can we sprint from research to innovation. And it involves, for example, or it starts with a technology intelligence, what we perform. So we search for keywords, we search for really relevant trends, for example, sustainable MRO to see, okay, what's out there. And then we try to do the sprints in 3 to 6 days. This is level 0. And then in the next level, we spent 3 to 6 weeks to really deep dive into a problem or an idea and analyze this. And if we have the positive outcome of this phase, we continue with level 2, which is a sprint from 3 to 6 months, where we really gain deep knowledge and demonstrate potential solutions. And in the end, we also look for the technology transfer to really contribute the demonstration, the technology to industry and society. So this is the kind of method that we used for this sprints and these examples and projects. So I would like to start with the first pillar, which is the environmental compatibility. And one example is engine wash. So engines have to be cleaned, and aircraft engine itself is a major cause of environmental impact and operating costs. So engine maintenance is one of the biggest cost factors in MRO. And let's not forget the critical safety relevance. So they need to be cleaned regularly. And the wash system is not only good for the plane, it's good for the environment. So it uses, if you use water, it's a bit old technique, but it uses basically atomized water and collects the effluent water and purifies it for recycled use. And it's stated that washing the engines will reduce the fuel or the engine fuel burn by as much as 1.2%, which is really huge number. And so there are improvements in the fuel efficiency, as I said, and also the cooler operating temperatures. So this is the effect of maintenance of the engine wash, only of the engine wash. And there are new methods now. There's a patented method using foam instead of using water, and it removes the dust and the dirt particles in the engine, which is even more sustainable. So the aircraft operation gets more sustainable, and the maintenance process itself, that's what I meant with the process itself, gets also environmental friendlier. Next example, what I brought is a project that we had on hydrogen leakage detection. So I told you we need to think about hydrogen if it should operate in an aircraft, and we should think about leakages, because it wouldn't be a good thing if we have leakages with hydrogen. So we try to use smart sensors. We combine different sensors to localize, so not only detect but localize where we have the leakage. So this works on the time series-based analysis. So then we can really get the anomalies and see where might be a potential leakage. And health monitoring is the outcome of this. And unplanned failure is the least sustainable option. So we want to have everything planned, every potential failure One colleague of mine once said, if it moves, it wears, and if it wears, you have to maintain it. So you can really think of this like a thing that you really have to do in every technical perspective of an asset. The second dimension is the energy efficiency. So we have a virtual MRO, which is basically another research area at our institute where we have digital models of processes, of supply chains and resources. And in addition, we also have simulations for complex process chains. So it enables basically to perform maintenance remotely, which obviously reduces the traveling and the transport. And this field collaborates or closely relates to the human-focused MRO research that I mentioned, and contributes to shaping a human-centered technology, which is more effective, more safe, and we have a sustainable execution of MRO operations. So we have a vision lab in our facility where we research on this kind of VR, AR technologies. We can see on the right-hand side, we can see a person wearing a VR HTC headset, and we can see on the lower picture, we can see what the user view is on the virtual twin. So basically, we can integrate sensor information, we can display the sensor information into the virtual environment. The next example that I brought is human health fuel tank inspection. So what we can see here is the inside of a fuel tank. And the fuel tanks are in the wings. So there's also a center fuel tank, but here we are in the right wing tank currently. And as you can see, it's not a good working environment. It's not safe, it's not comfortable, and as you get more into the end of the wing, you cannot really crawl into the tank. You just have to put your light into and your head into the access panel and just have a look with your head. So we talked to mechanics that perform or used to perform these kind of activities and tasks, and they didn't want to do it at all. So you can really think about, why no one has solved this problem, why the mechanics still have to do this manually. So we had a closer look into the problems. The first one, of course, the human health. We have non-ergonomic, as I said, and the potential is really to support the stuff. We have overhead tasks as well. So we have the complex preparation, as you can see, special equipment, and it's really difficult to focus on the value-adding task, which is inspect this safety-critical component. And the third dimension of this problem is the digital transparency. So when the aircraft every 12 years comes into the hangar for the big check, the D check, you don't know what is inside. You just don't know. So it can be a surprise. And to have this digital transparency before the aircraft is in the hangar really supports this efficient maintenance planning to even reduce the ground time of the aircraft. And this is what we want to do. We want to increase the aircraft time in the sky. So these are the problems that we identified. And let's have a look at a potential solution. We thought about, okay, what's the first question? How can we move inside a tank? What are potential ways to locomote in a tank? So we can crawl, okay, we can roll, we can walk, we can jump, fly, swim, dive. So this is like a creative, maybe you have heard of design thinking, creative approach to think about, okay, what are different ways to support this activity? And in the end, we came up with a diving endoscope, which we call the eloscope. And there is an endoscopic port where we can enter the tank, and you can see the mechanic really standing next to the tank and performing this maintenance activity in a better working environment. And I brought a video for this as well, just to illustrate how it works, at least in the lab. So this is the current status. So we're not diving, because diving is difficult and complex because of different reasons. But here we have a endoscope operating in a dry tank with stereo cameras to really inspect and to ensure that we have inspected every part of the inside of the engine of the tank, which in the end ensures really a sustainable process with no risk for the human, because the stories that we heard from human there is really horrible. Yeah. Intuitive control, and you can really see the person can really concentrate on the task. And the philosophy is to get the person outside of the tank, but keep their eyes inside of the tank. So, I think that's good for now. And with this impression, I would like to conclude my presentation. And if you ask me how to sum up the key message in one sentence, it would be, if you can't maintain it, you can't sustain it. And with this, I would like to conclude my presentation. I mentioned technology transfer earlier in the method, which is extremely important for us, for me. So I'm happy to engage in discussions for possible collaborations, maybe problems to be addressed. So feel free to connect and contact me anytime. And thank you very much.